students. I'm Prashansini Sandupini. I'm an undergraduate from Faculty of Medicine, University of Moratuwa. So I did previously most of the videos in Sinhala medium, but now onwards I like to meet my students with English medium materials, as I am also a student of English medium background, so I like to help them because they already lack most of the resources, even in online and any place. So today I'm going to focus on the unit 2 in grade 10 science. So let's move on, and if I want to explain deeply on something, and if I feel that the students can't understand with English, or if I want to change language, I will do in both, so you guys can understand more deeply. If you guys have any kind of questions regarding the lesson, so it's feel free to ask any questions in the comment section. So let's move with the unit 2, the motion in a straight line. So in here you have to first focus on what really means the straight line. So why they are focusing on the straight line? Because it's not on a circular paths, or it's not on angular pathways. They are focusing more on the straight lines. So because we already studied circular motions, angular motions in A levels under physics, so those are something different from the straight line motion. That's why it specifically mentioned this is a straight line motion. අපි ඉස්සරහට තමයි ඔය කියන විදියට angular circular motions ඉගෙන ගන්න. ඒතර මේ straight line එකක් specifically ඉගෙන ගන්න ඒක ඇත්තටම complexity එක අඩුයි, and also it's different. So let's move on. First of all, we have to know some words which are essential to understand the motion of object or a person or any other thing which is moving. Today we are not focusing on something which is static. Static mean what? එක තැන තියෙන දෙයක් ගැන නෙමෙයි අපි මෙතනදී focus කරන්නේ. Something moving. මොන හරි යමක් move වෙන දෙයක් ගැන තමයි මෙතන කතා කරන්නේ. So the most important two words we are focusing on here, first is the distance and the displacement. It's not something that is so complex, right? So it is very simple if you go through example. By in definition, distance is the total length of the path traveled by a body. But in displacement, it is the shortest straight line distance from the starting point to the final point. So if you consider this motion, think a person is in here at the point A, so it is the starting point, right? So that person want to go to the B. This is the finishing point. So he want to go from here to here. So that person can use different pathways. Can go through here, which is called as path P, or can move through this path, which is called path Q, or can move through this path which is called path R. So whatever the path he use, finally his goal is to move from A to B. So there is a starting point, there is a ending point. So this is his or her journey. එක වාහනයක් වුණා, එක vehicle එකක් වුණත්, whether it is a person, that person really want to go, a person ට යන්න ඕන A point එකේ ඉඳලා B point එකට. ඒ ගමන යන්න විදි ඔය කියන විදියට මේ පාරේ මොන හරි පාරකින් අපිට යන්න පුළුවන්. So those are paths he have. There are many options ගොඩාක් තියෙනවා. හැබැයි එක එක පාරට the distance also vary. එක එක path එකට distance එකත් වෙනස් වෙනවා. ඔයාලා බැලුවොත් එහෙම in path P you can see it's 320 meters, but in path Q it will take 200 meters, and in path R it will take 240 meters. So according to the path, the distance is also vary. Distance කියන එක ඔයාලා මේ definition එකෙන් බැලුවොත් total path එක. හිතන්නකො මේ man ගියේ මේ පාරෙන් කියලා. So එයාගේ distance එක 320 meters. But if the same person use this pathway, his distance is 200 meters. ඒක ගන්න pathway එක අනුව ඒ path එක අනුව මොකද වෙන්නේ? It's vary. ඒක වෙනස් වෙනවා. ඒක constant. Whether it is constant, it's not. Depend on the path. So distance can vary from the same points used, but distance can vary according to the path. But when you think about a displacement, it is the shortest straight line distance from starting point to finish point. This is the starting point, this is the finish point. Then you have to draw a straight line. But a straight line එක මෙහෙම එන්න බෑ. මෙහෙම ගිහින් bend වෙලා එහෙම වෙන්න බෑ. bend වෙනව නම් straight line එකක් වෙන්නේ නැහැනේ. So කොහෙවත් bendings, angles තියෙන්න බෑ. There should be no any angles, no any bendings for that pathway. It's a really a straight line. Okay, so from point A to point B there should be a straight line. There is no any angle, right? So if you draw a straight line from A to B, if you measure that length, ඔයාලා measure කරොත් මෙතන තියෙන length එක, it will give a value. It's not actually the distance. Okay, it is the displacement of point A to B. ඒකට එනවා value එකක් ඇවිල්ලා තියෙනවා how much 180 meters ලු. So මේ path එක ගැන අහලා ඔයාගෙන් ඇහුවොත් from point A to B what is the displacement? So the displacement should be 180 meters. I think you guys can understand. And there are 2 points you have to know before enter these quantities. I first have to mention when we are describing a motion in physics, we are using physical quantities. What is the word? Physical quantities. Okay, these physical quantities either can be scalar or a vector. What does really mean? Physical quantities කියලා තියෙනවා. භෞතික රාශීන් කියලා තියෙනවා. මොකක් හරි දෙයකට මොකක් හරි physically physics වල තියපු දෙයක් explain කරද්දී අපි මොකක් හරි parameter එකක් describe කරන්න අපි පාවිච්චි කරනවා. We can use the either words like time, speed, the mass, weight, like many words. අපි use කරනවා හරි physics වලදී අපි දෙයක් explain කරන්න. ඒවා physical quantities. අපි හිතමුකෝ ඒ physical quantity එකට only have magnitude කියලා. magnitude එකක් විතරයි නම් තියෙන්නේ. magnitude විතරයි නම් තියෙන්නේ. and direction එකක් නැත්තම් ඒ වලට අපි කියන්නේ scalar කියලා. magnitude එකක් තියෙනවා කියන්නේ as example දැන් හිතන්න magnitude එකක් තියෙනවනේ ඒකට unit එකක් තියෙනවා අපිට ඒක measure කරන්න පුළුවන්. ඒක තමයි ඒකේ සරලම meaning එක. දැන් මම ඔයාලට කිව්වොත් එහෙම සරලවම හිතුවොත් දැන් මම මේකේ distance එකක් නෙමෙන්නේ. ඒක මයින්න පුළුවන් නේද ළමයි කියලා. It can be. You can measure that distance, right? Because if you take a tape or something, you can really measure it. So it is coming under meters or centimeters or kilometers, whatever the unit, you can measure it. But for scalars, there is no direction. Eka, you can see in this way. If you see path P, Q and R, you can see whether there is a specific direction. No, right? It's first going in this way, then this way, this way, this way. Likewise, it's become a mesh. So there is no any unique one direction. So it's already changing. We are not focusing on under scalar. There is no any specific direction. So that is the point you have to keep in your mind. And then under the vectors, the magnitude and the direction both have. That means like displacement. You can measure the displacement or the distance between the A and the B. You can measure that value. It is coming as the 180 meters. And also there is a one specific direction because it is a straight line. එක straight line එකක් නිසා you can measure that direction, right? You can යාට කියන්න පුළුවන් direction එක from A to B. What is the direction? East. That's why it is mentioned in this figure. It is east. I think you guys got what is scalar and what is vector. These two words are essential to describe the upcoming terms too. So keep in your mind these two words, right? Scalar and the vector. So you have to focus on these words. That's why scalar and the vector. Distance only have the magnitude, but for a vector it has both magnitude and the direction. I think you got what really it means. So as I said, for the distance it depends on the path. For the displacement it is not depend on the path. path එක මොකක් වුණත් වැඩක් නෑ. path PQ මොකක් වුණත් වැඩක් නෑ. අන්තිමට displacement ගන්න අනින්න එක straight line එකයිනේ. so ඒක depend වෙන්නේ නෑ path එකේ. මේකේ path එක අනුව වලට පේනවා values වෙනස් වෙනවා. that depend on the path and the distance value is changed according to the path. I think you guys got what really means. Okay, so I think here it is mentioned what is scalar and what is vector too. Okay, only magnitude එකක් තියෙනවා නම් it is a scalar. both magnitude and direction තියෙනවා නම් that is vector. So ඒකට examples also given, right? The speed, the mass, time, distance only have the magnitude. There is no, when you are telling the time, I got 6 seconds to come to school, and I whether I am telling a direction to the time? No, right? අපි එහෙම time එකක් කියන්නේ direction එකක් කියන්නේ නැහැ නේද? මේ මට 1 hour ගියාද school එන්න and it also has this kind of direction කියලා එහෙම අපි දිශාවක් කියන්නේ නැහැ, right? So it doesn't have a direction, but these quantities have a direction, right? So when you're moving through the upcoming lessons in future, when you're learning more on physics, you will understand these terms very deeply. So then you guys can understand what really means this direction is, right? So දැන් මම මේක හිතලා very stressful වෙන්න එපා. With the time you will learn this more deeply. So let's move on to the speed, right? Okay, before moving to the speed, I think as this is a physics lesson, after learning you have to practice what these are, unless nothing going to your mind. Okay, so I like to do some questions. So let's move on. Actually I got these from internet, so we'll see. Okay, they given like a diagram. Okay, so you can see a nice boy is there, right? So that young boy want to get his cat and travel to his house and to play under a tree or maybe come again. Likewise you can see something is there. Okay, we'll see whether they ask a question. Okay, if I ask, you can see. Okay, if I ask a question like this, think that boys start to travel from A to B to C. Then I ask, what is the distance? What is the distance? You can pause the video if you like, or if it's directly coming to your mind what is the distance, you can work out. Okay, if you want a break, you can pause the video while I'm discussing questions. First I'm showing the questions to you, so you guys can look at what is the question is. Okay, so if you want to work out by yourself without listening to my explanation, you guys go ahead. Okay, so pause the video and find out what is the distance of this boy when he traveled from A to B to then C. Okay, I think you guys got distance mean what? The total distance. So distance becoming distance from A to B, that is 4 meters, and from B to C, that is become 3 meters. The total it's become 7 meters. That is the distance. Okay, But if I ask what is the displacement of this boy, now think quickly. But maybe it's already marked. So how to find the displacement? Pause the video, think. So from A to C, no, so A is the starting point, right? When you find in the displacement, first find what is starting point and what is finishing point. Then it's become more and more easy. So from A to C, you can draw a straight line like this. So you can see it's marked as 5 meters. So definitely the displacement become 5 meters. And you know there is a rule when you tell the displacement as it is which kind of a quantity, whether it is a scalar or a vector. You know distance is scalar, this is vector. So there is a direction for that. So that's why it's marked as this way. But if you can tell what is the direction is, like this is north and this is east. If it's really the middle, you can say it is northeast. Okay, likewise you can tell the direction. Then my students, you can go to the next question. So in here it's given like this. Think if this person is moving from A, then B, then C, then D, then A again. Okay, this is a tricky question, right? Now think. Now this person is different from that previous case. Now this person coming back to the same point after traveling a distance. Now you can guys use your knowledge and think what is distance and what is displacement. Pause the video and think little bit what would be the distance and what would be the displacement. So distance එක ගත්තහම first you have to think total distance. How much? From A to B it is 3 meters. Then from B to C it's become 5 meters. From C to D again 3 meters. You can see the same distance from here and here. So again 3 meters, and again when we come here 5 meters. So how much is the distance? Is become 5 is 10, 3 is 6, 6 plus 10, 16 meters. Sure. So that is the question. Distance is 16 meters, but when you think about displacement, how much is it? You can pause the video and think. If you really think, you have a doubt. When you're thinking about the displacement, you are taking the starting point and the ending point. Can you see the starting point? It is point A. And also the ending point, also point A. So how to draw a straight line? You can't draw, right? That means displacement equal 0 meters. And also you can't tell the direction because there is no displacement here, right? So that is a tricky way of thinking about the distance and the displacement. I think from these students we can continue our lessons. I think in previous one we already did some calculations regarding to distance and displacement. From now onwards we are moving to the speed velocity concept, and at the end we can do some velocity and the distance displacement, and likewise these concepts all together we use to make some graphs, and we can go deep dive onto these concepts after learning these. So one of the most important words we already learned in previously as well, like distance, displacement, and now also we are going to learn speed and velocity. So what is speed? Speed කියන එක ඔයාලට සාමාන්‍යයෙන් it's also very common, right? in daily life නිතරම ඔයාලට ඇහෙන දෙයක් ස්පීඩ් එක අඩු කරන්න කියයි වාහනවල යද්දී එහෙම ඔයාලට සාමාන්‍යයෙන් ස්පීඩ් කියන වර්ඩ් එක නිතර ඇහෙන වචනයක්. So from the definition, speed is the rate of the change of the distance with the time. ඔයාලට rate කියන word එක ටිකක් අලුත් ඇති. rate කියන word එක අපි time එකත් එක්ක වෙන වෙනස. If something is changing with the time, we are using the word rate, right? So rate of the change of the distance. Distance කොච්චරක් වෙනස් වෙනවද with the time. කාලයත් එක්ක. කාලය ගලනවනේ. එතකොට ඒ කාලයත් එක්ක object එකක වේවා for a object or a person can change its distance, right? ඔයා move වෙනවා කියලා හිතන්නකෝ. ඔයා එක තැනක ඉඳන් තව තැනකට move වෙනවා. So ඔයාගේ distance එක මොකද වෙන්නේ? time එකත් එක්ක වෙනස් වෙනවා. එතකොට this is same for a object, vehicle, anything which is under motion. So speed can be calculated with this equation. It is the distance divided by time, right? You know the unit of the distance. Distance we measured in meters, which is the standard unit, right? It doesn't mean that the speed only can be calculated with the meters and the time is measured with the seconds, only with that. එහෙම කියනවා නෙමෙයි. මේකෙන් විතරක් මනිනවා කියන එක නෙමෙයි. අපි දන්න ස්පීඩ් එක අපි usually commonly use කරන vehicles වල මේවල නම් kilometers per hour කියන එකනේ. So it is a very kind of common unit, but as standard international standard unit, it is the meters and the seconds. Okay, that's why it's given the unit is this one. අපි සාමාන්‍යයෙන් papers වල calculations ආන්නේ meters per seconds වලින්. හරිද? And previously ඔයාලා ඉගෙන ගත්තා the scale and the vector word. I said to become a scalar only the magnitude. ඒ කියන්නේ ඒක measure කරන unit එකක් තියෙනවා, measurement එකක් විතරයි ගන්න පුළුවන්. අපිට speed කියන එක value එකකින් කියන්න පුළුවන්. හැබැයි ඒක direction එකක් කියන්න පුළුවන්ද බෑ. direction එකක් නෑ specific. ඒකට හේතුව තෝරලා බලද්දිම පේනවා මේ equation එකේ speed හොයන්න අපි පාවිච්චි කරන කෙනා කවුද? distance. අපිට මතකයි නම් previously ඉගෙන ගත්ත distance කියන එක scale එකක්. කියන්නේ යාට direction එකක් නැහැනේ. එයාට direction එකක් නැතුව speed වලට කොහොමද direction එකක් එන්න බෑ. කියන්නේ නිතර වෙනස් වෙනවා නම් direction එක. ඒට specific direction එකක් කියන්න බෑනේ. ඒක නිසා තමයි speed එකට direction එකක් නැහැ. හින්දා ඒක scale quantity එකක්. මං හිතන එක තේරෙන්නේ නැති. And there are some specific words you should learn under the speed too. That is uniform speed and the non-uniform speed. What this mean? Uniform කියන word එකෙන් ඔයාලට කියන්න පුළුවන්. Uniform නැත්නම් අපි ඒකට කියනවා constant කියලා. They are constant නා uniform නම්. හරි දැන් අපි specifically හිතමුකෝ uniform කියන word එක අපි දැන් school එකේ යන uniform ඇඳුම හිතන්නකෝ. ඒක අපිට වෙනස් කරන්න පුළුවන් ද කැමති විදියට. අද මං ආසයි මෙහෙම යන්න. So I am changing this. Can we do that? We can't, right? That word is also coming like that. Uniform means that is not changing, right? It's whatever the thing happening, it's already constant, or it's not changing. That is the meaning. Okay, so speed එක uniform කියලා කිව්වොත් ඒ කියන්නේ අපි හිතමුකෝ vehicle එක වේවා ඒක යන්නේ එකම මේ speed එකකින්. ඒ කියන්නේ එක වෙලාවකට බලද්දි 20 meters per second වලින් යන්නේ. ආය විනාඩි 5කින් බලුවොත් එයා යන්නේ කොහොමද? 20 meters per second ම තමයි. මේ timeline එකේ කොහේ බැලුවත් time එකේ බැලුවත් එයා යන්නේ එකම speed එකකින් නම් ඒකට අපි කියන්නේ uniform speed කියලා. හැබැයි ඉතින් most of the time අපි අත්තම vehicles ගත්තොත් අපි ඇවිදන් යන විදිය ගත්තත් ඒක බොහෝ දුරට uniform නෑ. ඇත්ත real life එකේ. මොකද ඒව වෙනස් වෙනවනේ. එකම speed එකකින් අපි යන්නෙත් නෑ. වාහන යන්නෙත් නෑ. සමහර තැන්වලදී නවත්තන්න වෙනවා, ආය යන්න පටන් ගන්නවා. එතකොට ওই speed එක අඩු එකකින් ඉඳන් වැඩි කරගෙන යනවා. සමහර වෙලාවට තමයි constant යන වෙලාවල් තියෙන්නේ. So ඉතින් මේක uniform නෑ speed එක. එහෙම තැන්වලදී අපි ඒවලට කියන්නේ non uniform speed නැත්තම් it is not constant, right? So distance එක time එකයි vary වෙන විදිය ගත්තොත් ඒ වගේ motion වල දැන් අපි දන්නවා 20 meters per second කියන්නේ එක තප්පරයකට යන්නේ 20 meters. For 1 second it is moving 20 meters. So it is not, if it's not changing, ඊළඟ තප්පරේ බැලුවත් යන්නේ 20 meters මයි, next තප්පරේ බැලුවත් යන්නේ 20 meters මයි. හැබැයි if it is not uniform, what happen? එක වෙලාවකට බලද්දී මීටර 10ක් යනවා එක තප්පරයකට, ඊළඟ වෙලාවකදී බලද්දී 20 meters යනවා. එහෙම it can be very. මම කියපු concept එක තේරුණා නම්. හරිද? ඊට පස්සේ ඔය ඔක්කොඩ වලින්ම පස්සේ ළමයි තියනවා the mean or the average speed. Mean or the average speed. What this really mean? මොකක්ද මේකේ meaning එක? mean එක නැත්නම් average එක. මේක ඔයාලට class වල term test ලකුණු එහෙම දෙද්දී if you focus on your report card after giving your term test mark, if you go at the bottom of that page, you can see there is a word like average or a mean. ඒ කියන්නේ ඒක කොහොමද අපි ගන්නෙ? ඒ ලකුණු වල average එක කොහොමද ගන්නෙ? අපි ඔක්කොම subjects වල ලකුණු ටික අරගෙන ඒ ඔක්කොම එකතු කරනවා. අපි හිතමුකෝ maths වලට 20යි තියෙන්නේ. It's not good, right? It's coming to my mind like accidentally it came and I know it's not good, right? Okay, it's 20. Abhi to me, let's take it as not for the maths, right? It's like for Tamils or something, because I know most of the students are struggling these languages, right? Okay, and think about your science mark is 65, and then think about your maths mark is like 70. So how would you take your average if you think you have 3 subjects, right? So you can add these and you can take the summation. And likewise 8 and 7 150. Okay, then you are dividing by the number of subjects, which is 3. Then you are taking an answer. So that's the way you are taking an average. Average එක ගන්න අපි තියෙන ඔක්කොම ඒවා එකතු කරලා ඉවර වෙලා කීයක් subject තිබ්බද කියන එකෙන් බෙදලානේ. So likewise අපි mean speed, average speed ගද්දී distance එක නම් අපි travel කරපු ඔක්කොම distance එක add කරලා උඩට දානවා. time එකත් ඔක්කොම time එක යටට දානවා. ඒ දෙක බෙද්දාම එන්නේ අපිට mean speed or the average speed. අපි මේකෙන් calculations කීපයක් හදමු. එතකොට I think this will be going to your minds more than I am explaining this way. Okay, so let's move to some questions, and I want to tell that I got these tables from your textbook because I think those are the things you already should follow. In my mindset, you should know your textbook things well than you're practicing any other thing. So that is the core syllabus, right? So let's move on with the tables that taken from your textbook, right? So in this table it's mentioning how the time vary and how the distance is of that object with the time. Okay, think at the 0 second. That means the motion is not start yet. තාම motion එක පටන් අරන් නැහැ ළමයි. හරිද? එතකොට ඒක අපි ගත්තොත් 0 second නේ. So 0 second වලදී distance එක කොච්චර travel කළද? එයා තාම travel කරලා නැහැ. මම කිව්වා තාම ගමන පටන් අරන් නැහැ. So at the 0 second nothing has moved, right? So the distance is 0. Focus, the word is distance. I am not talking about the displacement because we are under the speed lamai. So after 1 second measure කරලා බලද්දී starting point එකේ ඉඳලා object has moved 3 meters. Okay, 2 seconds ගිහිල්ලා බලද්දී object එක move වෙලා තියෙනවා 6 second. Likewise මෙන්න මේ විදියට mark කරලා තියෙනවා 3 second යදී 9 4 12 likewise ඔන්නෝම පෙන්නලා තියෙනවා. ඕකේද? එතකොට ඔය විදිහට තමයි තියෙන්නේ. So if I ask a question, students, calculate the speed of this object. How you guys find it? So how to find it? Speed equal, you can pause the video and you can think distance divided by time, right? So what is the distance here? More specifically, if I ask the question, what is the speed of this object at 4 seconds? අපි තුමු මේ 4 seconds වලදී තියෙන ස්පීඩ් එක අහනවා කියලා මම. එතකොට distance එක එයා ඒ වේදී travel කරලා තියෙනවා කොච්චරක්ද? මෙතන ඉඳන් මුල් පළවෙනි එකේ ඉඳන් 12 meters, right? Then the time is 4 seconds. So you can divide 12 by 4, which is coming 3 meters per second. ඒ විදිහට අපිට හොයන්න පුළුවන්. ඕක 6 second වලදී හැවත් 5 විදිහට හැවත් ওই විදිහට හැවත් what to do and you can calculate, right? If it's asked we can do it, right? We'll see how it's coming. So first second එකේදී එන්නේ 3/1, right? එතකොට වෙන answer එක මොකද්ද? 3. මේ second එකේදී හැවත් second එකේදී හැවත් එන්නේ 6/2, which is also 3. 9/3 also 3. 12/4 is also 3. 15/5 3. 18/6 also coming like 3. එතකොට ඔයාලට පේනවා at each second the speed is 3 meters per second කියලා එනවා. That means අර ඉගෙන ගත්ත knowledge එකෙන් කියන්නේ whether this is uniform or non-uniform speed එකක් තියෙන object එකක්ද. I think it is uniform speed object, right? Because you can say at each and every second it maintain the same speed. ඔයා කොයි වෙලේ measure කරත් ඔයාට එන්නේ එකම speed එක. This is not a non-uniform thing. හරිද? ඒකත් මම හිතනවා ඉගෙන ගන්න ඇති. So and also there is another table. The second table you can calculate. Now you guys can pause the video and calculate the speed for each second. Then let me know whether this is a uniform motion or a non-uniform motion. Pause the video and you can calculate it. Hope you guys calculate. So at this point the speed equals, let me write the equation. In the exam students you have to write the equations and you have to mention the units as well, unless you can't gain the marks, because for the units, for the equations they are allocating marks, so don't miss that, you will lose marks. So distance is 3 meters, time is 1 second, that is 3 meters per second. Likewise if you do the same for here, distance is 5 and the time gone to, but this become 2.5. Here 9/3 it's become 3. Here 12/4 again 3. 16/5 and here the 18/6 it's become, you can observe in the previous case, I mean the 16/5 case, it's become 3.2, right? So you guys can now see the difference between the previous motion and this motion, right? That's why I took this. So this is 3 meters per second one, right? But here it's become 2.5. That means 3 වෙලා ළමයි මොකද වෙන්නේ? 3 වෙලා it's become 2.5. We can අඩු වෙලා speed එක. Then again come back to the 3 and again go to the 3.2, another higher value, and then it's come back to the 3. ඇත්තටම real life එකේදී මේ වගේ motions තමයි තියෙන්නේ. ඒ කියන්නේ constant මේක uniform ද? මම හිතනවා මේක uniform නෑ කියලා පේනවා. ඒතර මේක non uniform speed එකක් තියෙන object එකක්, right? එතකොට මේක uniform එකක්, මේක non uniform motion එකක්. okayද? එතකොට non uniform එකක් තියෙන වෙලාවදී ළමයි we can't ask exactly what is the speed of the object නේ. අන්න ඒ වගේ වෙලාවට අපි කරන්නේ we are asking a question like what is the mean speed? Students, you can see in here there is no uniform motion in here. First it's become like 3 and then 2.5, then 3, 3.2, likewise it's changing now. So it's a non-uniform motion. So in that kind of cases we are not calculate the normal speed, right? It's now it's obvious at each point it's becoming changing, right? So we are asking the mean speed of the object or a person's motion, right? Likewise in your report card we are not asked if to get an idea how your knowledge on whole your subjects that you already learn, we are asking about your average, how you perform for everything. As an average we can identify how you focus for everything at once. So to do that we are using the mean speed, right? To calculate that, mean speed equal what? the total distance divided by total time. So in this, the total distance is the 18 meters and the total time is 6 seconds. So 18 over 6 is 3 meters per second. It doesn't mean that at every point you are taking it's become 3 meters per second of speed. It means like if you take the overall, you can take an idea it's become like it's close to 3 meters per second that object is travel. That's the main idea. We are going to focus on the velocity now. Now we already discussed about the speed. You know, speed is a scalar quantity. Now when it's come to the velocity, it's becoming a vector quantity which has a direction now. Okay, so the only thing that is changed from the definition is the rate of change of displacement. In previously we learned the speed is the rate of change of distance. Now this is displacement. You know, displacement is a vector, right? It has a specific direction. You know, the shortest distance between the starting point and the ending point. So velocity has a direction and the magnitude. So when it's come to the magnitude, you know, the displacement is also measured in meters and the time is seconds. So that's why the unit become meters per second, same as in the speed. But here we have a direction. That is the only change, right? And also the displacement here, but in speed, that is distance. You have to know. When you are studying, likewise you have to compare and contrast what is different from the thing that we learned previously. ඒක තමයි ළමයි කියන්නේ ලොකුම skill එක when you are learning, you have to compare what is this and what is this, what is different from this. Then ඒක වගේ mind එකට එනවා more deeply than the other way. Okay, so when it's come to the uniform velocity, it's become the equal displacement in every time interval. That means ඔයා ගත්තොත් a person move වෙලා තියෙනවා 3 meters per second velocity එකකින්. That means එක සෙකන්ඩ් එකේ බැලුවත් second second එකේ බැලුවත් third second එකේ ඔයා calculate කරලා බැලුවත් velocity එක එකම තමයි. ඒ කියන්නේ එයා යන්නේ 3 meters ම තමයි ඒ හැම තප්පරේම බැලුවත්. හරිද? ඒකයි කියන්නේ මේ equal displacement එකක් තියෙන හැම time interval එකේ බැලුවත්. හැබැයි as I mentioned for the non-uniform speed concept also the same thing. Displacement එක vary වෙනවා, irregular vary වෙනවා time එකත් එක්ක. එක වෙලාවට යන්නේ එක වෙලාවට, එක වෙලාවට 3 meters per second and the next time that person have a 10 meters per second velocity. Likewise it's changing, right? Same concept as in the speed we can calculate in that kind of situation. අපි නිකන් rough idea එකක් කියන්න පුළුවන් වෙන්න බෑ emotion එක ගැන. ඒ වුණාට දැන් කීක velocities තියෙනවා. ඒ වුණාට මට නිකන් emotion එක ගැන idea එකක් ගන්න මට දෙන්න පුළුවන් ඒ වෙලාවට mean velocity නැත්නම් average velocity කියන එක. අර ළමයින්ගේ ලකුණු එකතු කරලා add කරලා average එක හොයන්නේ. ඒ වගේ මේකෙදි වෙන්නේ total displacement එක total time එකෙන් බෙදෙනවා. ඉස්සෙල්ලා concept එකමයි. I think you can go through the questions and learn more. We came to the velocity part now. Make out also taken from your textbook, right? So let's move ahead. Pause the video and find the velocity of this object at 3 seconds. Okay, at 3 seconds. Find and calculate it. And then calculate about the velocity at each of second. That means at the first second, second second, third second and the fourth second of this journey. And tell me whether this motion is a uniform one or a non-uniform one. I want to know the both answers, so you can pause the video and you can calculate it. Okay, students, you can calculate for third second. First you have to write the equation, which is the displacement divided by time, right? So the displacement here is the 9 meters, time is 3 seconds, right? So it's become 3 meters per second. That is the velocity, right? So now it's easy because you have a practice on the speed also. So quickly we can grow. 4 over 1 equal 4. Here 7 over 2 equal 3.5. 9 over 3 is 3 and here 12 over 4 is 3, right? Mammukut units lammene just to take an idea on what about the velocity on each case. So each and every second you can see that the velocity is changing, right? At first second it's become 4 and then it's become 3.5 and 3 and 3, so it's changing. Now according to the previous knowledge you can tell this is which kind of motion, non-uniform velocity motion. Okay, I think you guys got the point too. Then there is another question. This is also taken from your textbook. I think the standard questions are given in your book to practice first. Then you guys can go through with your term test papers or the past papers to get a more idea. But first start with your textbook and learn how the basic is going on, right? So here is given the displacement and the time. Okay, how it's vary with the time. So let me start from the question. The variation of the displacement measured with respect to the starting point. It's measured from the starting point. Why? Because the displacement, right? Displacement to measure starting point, ending point. Starting point, ending point. ඒ දෙක අතරම තියෙන distance එක measure කරන්න හැම වෙලේම. හරි. ඒ විදිහට measure කරලා ගන්නවා. child කෙනෙක් ride කරනවලු bicycle එකක්. Okay? In a straight pathway each second වලදී measure කරනවා එයාගේ displacement එක. හරිද? ඒ කියන්නේ starting point එකේ ඉඳන් කොච්චර දුරකින්ද මෙයා ඉන්නේ කියලා හැම වෙලේම එක second එකක ගානේ measure කරගෙන plot කරනවා මේ table එක. Okay? The first question is, what kind of motion has the child undergone during the first 4 seconds? මේ first 4 second වලදී තමයි අහන්නේ. What kind of motion? motion එක ගැන කියන්න නම් ඔයා මේකේ හොයලා බලන්න ඕන. දැන් ඔයාට හොයන්න පුළුවන් displacement නිසා velocity හොයන්න පුළුවන් නේ. ඔයාට velocity හොයන්න පුළුවන් එක එක seconds වල. අපි හිතමුකෝ first second එකේ කියලා. ඒ second එකේ තියෙනවා 2 meters 1 second 2 meters per second. Second එකේදී මොකද වෙන්නේ? 4 over 2 means 2 meters per second. When I am explaining, sometimes I'm missing units and equations and everything, but students, you can't do that, right? So keep in your mind, at the 3 second what happened? 6 meters over 3 seconds, which is coming 2 meters per second. At the 4th second what happened? 8 over 4, which is also 2 meters per second. Then the students, you can get an idea මේක මොන වගේ motion එකක්ද. හැම second එකේම velocity වෙනස් වෙලාද? නැහැ. එහෙනම් මේක වෙනස් වෙලා නැත්නම් මේකට කියන්නේ මොනවාද? uniform velocity. එහෙනම් මේ object එක move වෙලා තියෙන්නේ කොහොමද? uniform velocity එකකින්. It doesn't change with the time. Okay? Then asking, what is the rate of the change of the displacement during the first 4 seconds? Rate of change of displacement mean එක දෙන්න පුළුවන් single term එක මොකක්ද? If you can't answer my questions, please pause the video and think a little bit, then listen to my answer. Okay? Rate එකක් කිව්ව මං කිව්වා කාලයත් එක්ක වෙනස් වෙන එක. ඒ කියන්නේ displacement එක කාලයත් එක්ක වෙනස් වෙන එකට කියන්නේ මොකද්ද? Displacement divided by time. What is that equation is? That is for velocity, right? So මේ වාක්‍යයෙන් මෙච්චර කියලා තියෙන්නේ what is the velocity during first 4 second. ඔයාලා velocity එක මෙතන හෙව්වා නම් ඔයාලට පේනවා දිගටම එන්නේ මොකක්ද ආන්සර් එක 2 meters per second. ඕනනම් ඔයාලට මේක මේ විදියට roughly කොහේ හරි calculate කරලා තියාගෙන ඔයාලට කියන්න පුළුවන් this is uniform velocity කියලා. මොකද මට නම් මේක බලද්දිම පේනවා uniform velocity කියලා. ඒ බැරි නිසා තමයි මම ඔයාලට කිව්වේ මේම ඔයාලට ගන්න බැරි නම් you can calculate in separate paper and you can write it is uniform velocity only. දැන් මේක definitely අහනවානේ. හින්දා ඔයාලට second question එක roman number 2 දාලා ලියන්න පුළුවන්. Rate of change of displacement කියලා ලියලා equal to displacement divided by time. I'm not writing the whole equation because of the time limitation. So displacement here is the, what is the displacement in first 4 second? 8 වෙනකන් ගිහින් තියෙනවා 8 meters and the 4 seconds which is giving 2 meters per second, right? So ඒ විදියට ලියන්න පුළුවන්. මං හිතනවා ඒක තේරෙන්නේ නැති කියලා. So oh my god, it will take all right. It's asking. Okay. Students will write somewhere else the answers. So it's asking, give one word to describe the rate of change of displacement. What is the word? එකත් මම explain කරා ළමයි. It is velocity නේ. It is previously one mention kara. What can you say about the motion of the child during the time period from 4 to 8 seconds? Asking from 4 to 8 seconds. What happened? ඔයාලට පේනවා 8 8 8 8 8. ඕනනම් ඔයාලට ඔය කියන දේ velocity calculate කරන්න පුළුවන්. 8 over 4. ඒ කියන්නේ දැන් මේක ගත්තොත් නම් දැන් මෙතෙන්ට වෙනකන් අපි හෙව්වනේ. දැන් මේක asking from 4 second to 8 second නේ. මොකද වෙලා තියෙන displacement එක? whether it is change. displacement එක වෙනස් වෙලා නැහැ. so motion එක ගැන මොනවද කියන්න පුළුවන් කියලා. when displacement එක change වෙලා නැත්නම් එහෙනම් මොකද වෙලා තියෙන්නේ? ඒ කියන්නේ ඔන්න මම තප්පර 4දී බලද්දිත් ආයා ඉන්නේ ස්ටාර්ටින් පොයින්ට් එකේ ඉඳන් 8 meters දුරින්. ඔන්න මම තප්පර 5 එබිල බලද්දිත් එයා ඉන්නේ තාමත් 8 meters දුරින්මයි. ආය තප්පර 6 එබිල බලද්දිත් ඉන්නේ 8 meters. meaning මොකක්ද ඒකේ තේරුම? මේ child move වෙලා තියෙනවද මේ seconds 4දී? ඇත්තටම කිව්වොත් නැහැ. හරිද? ඒක තේරෙන්න ඕන. හරිද? ඒක calculation එකක් නෙමෙයි. ඒක logically හිතන්න ඕන. 8 8 කියන එකේ meaning එක තමයි displacement එක වෙනස් වෙලා නැහැ. ඒ කියන්නේ යා කොහෙටවත් move වෙලා නැහැ. හරිද? starting point එකේ ඉඳන් මීටර 8ක් දුරින් ගිහින් යා නැවතිලා bicycle එකේ ඉඳලා until this 8 second. එතකොට what can you say about Q armor? The child is at rest or something like that you can write. Okay. Describe the motion during the time interval from 8 second to 10 second. Me asking about this part, right? මොකද වෙලා තියෙන්නේ? Describe the motion. මොකද වෙලා තියෙන්නේ? 8 meters දුරින් තමයි ඉන්නේ 8 second එකේදී. හරිද? 8 මම මේකකින් අඳින්නම් 8 මේ starting point එක. ඒකෙන් 8 meters දුරින් තමයි ඉන්නේ එක වෙලාවක බලද්දි. ඊළඟට බලද්දී ආ ඉන්නේ 4 meters නේද? 9 second එකේදී බලද්දී ඉන්නේ starting point එකේ ඉඳන් 4 seconds ලු. 4 meters ලු. 10 වෙද්දී ආයෙ බිඳුව වෙලා. ඒ කියන්නේ මොකද්ද? එයා මෙහෙම 8 meters ගිහිල්ලා ආයෙ එතෙන්ටම ඇවිල්ලා තියෙනවා. He come back to the same point which is he already start his journey. Okay? That's why the displacement becomes 0. So what can you say about that? Describe the motion. So you can describe like this. The child is come back to, or child came to the starting point again, or something like that, which is coming to your mind. What is the thing coming to your mind? You can write in your own word, right? Again, specific word එකක් නෑ ළමයි. You can write whatever the things coming to your mind. Find the velocity of the child during the last 2 seconds. Velocity එක අහනවා for the last 2 seconds, right? So for the last 2 seconds, when you asking about the velocity, last 2 seconds වලදී එයා කොච්චර displacement එකක් සහ time එකක් ගියාද? last 2 seconds පටන් ගද්දී ආ 8 second එකේදී ඉන්නේ starting point එකේ ඉඳන් 8 meters දුරින්, right? එයා ඒ seconds දෙක ඉවර වෙද්දී ආයෙ මෙතෙන්ට ඇවිල්ලා තියෙනවා. හරිද? එතකොට එයා කොච්චර displacement එකක් travel කරලා තියෙනවද? 8 meters. And also that person travel for about 2 seconds. කොහොමද ඒක විසඳන්නේ? I cleared some space. I think we have now space to calculate this. Lamai, I forgot to tell you another way of writing the equation for the velocity, right? Velocity equals change of displacement. That means අපි displacement කියලානේ ගත්තේ. displacement change කියන එක තමයි අත්තම meaning එක. ඒතර මේක ගද්දී ඇත්තටම අපි කළේ මම මේක නොකියුවට ඒක අපි කළේ ළමයි final displacement එක initial එකෙන් අඩු කරලා තමයි ඒ ගන්නෙ. හරිද? because in this case ඔයාලට direction එක මට පෙන්වන්න ලේසි. ඒකේ ලස්සනට minus mark එකක direction එක එනවා. මේ ළමයා ආපහු හැරිලා කියලා පෙන්වන්න හොඳම උදාහරණේ ගන්න. You have to use this equation. Then you can see definitely the minus mark. ඒක මම explain කරන්න. හරිද? අපි මේකෙන් යන්කෝ. එතකොට final displacement එක මෙයාගේ තියෙන 0 නේ. 0 meters. Initially පටන් ගද්දී එයාගේ displacement එක තියෙනවා 8. එයාට ගිය කාලය තමයි 2 seconds. එතකොට ළමයි -4 meters per second කියලා උත්තරයක් එනවා. මේක දැන් අලුත් දෙයක් නෙමෙයි. This is not a very new thing. You can use the same equation for the previous things also. That is how we already calculated. We just look at this and we usually take the displacement value by guessing this is 6 and this is 4 means you really take 6 minus 0. 4 minus 0 නේ. එහෙම බලලා තමයි මෙච්චරලා ගත්තේ. So I just add this equation. Now you can see the minus mark. මේකේ වෙන opposite නේ. මේකේ ඔයා මේ region එකේ ගත්තාම final එකයි initial එකයි ගත්තාම ඔයාලට එන්නේ අඩු අංකයකින් වැඩි අංකයක් අඩු කරන්න. So then become minus. මං කිව්වා velocity වල direction එකක් තියෙනවා කියලා. So you can see this minus mark. That means this child start to move in the opposite direction. That's why it's become minus. හරිද? මේ විදිහට ලියලා තියෙනවා නම් I think they will give full marks. Okay? මම හිතනවා මේ doubt එක clarify වෙන්න ඇති කියලා. Okay. දැන් අපි ඊළඟ part එකට යමු මේ lesson එකේ which is the acceleration. Okay? මේ all the terms are very closely related, right? Acceleration වලින් පස්සේ අර main terms ටික ඉවරයි. ඊට පස්සේ අපිට කතා කරන්න දෙන්නේ graphs ටික. So when it's come to the acceleration mean the rate of change of velocity. You know the rate එකක් අපි කියන්නේ මම කිව්වා when something is changing with the time. time එකත් එක්ක වෙන වෙනස බලන්නේ. ඒතකොට velocity කොච්චර වෙනස් වෙනවද time එකත් එක්ක. That's why it's right in this equation as changing velocity over the time taken. As I previously mentioned, this initial final something, it's also coming in here. Lamai, instead of this also you can write like this. Why is the equation here, no? You guys can write displacement එක වෙනුවට නැත්තම් ලියන්න පුළුවන් ඔයාලට final displacement minus initial මම වගේ abbreviations don't use, right? You have to write completely and the time taken. Okay? Now the change in velocities can be written as final velocity minus initial velocity and the time taken. So the velocity and unit එක මොකක්ද? meters per second, right? ඒක කලින් හෙව්වනේ. එතකොට time එක seconds. එතකොට අපි දන්නවා මෙතනදී නම් මේ second කියන එක උඩට අරන් යද්දි මොකද වෙන්නේ? මම දන්නේ ඉංග්‍රීසි සේවා කරලා තියෙනවද කියලා. සාමාන්‍යයෙන් උඩ තියෙන power එකක් මේ උඩින් යටින් උඩට අරන් යද්දි හරි උඩින් යටට අරන් යද්දි හරි මේ වල තියෙන sign එක මාරු වෙනවා. ඒ කියන්නේ දැන් මේ seconds කියන එක උඩ ඉන්නේ ඇත්තටම +1 එකක් නේ අපිට හැඩ නොපෙනී. එයා මොකද වෙන්නේ උඩට යද්දි -1 එකක් වෙනවා. එතකොට මොකද වෙන්නේ? -1 ට තව -1 එකක් ඇඩ් වුණාම -2 කියලා වෙනවා. ඒක තමයි වෙන්නේ. හරිද? එහෙම ලියන්න පුළුවන්. නැත්නම් මේ විදිහට තියලා තියන්න පුළුවන්. ඒ කියන්නේ m යට s ස්ක්වයර් කියලා තියලා තියෙන්නේ. ඇත්තටම මේක ඔයාලා ලියාගන්න. ඒක මේ විදිහට නෙමෙයි ලියන්න ඕන ඔයාලා. මෙන්න මේ විදිහට තමයි ස්ටෑන්ඩඩ් විදිහට පොතේ ලියන්න ඕන. මේක වැරදි නෑ. මේක හරි දෙයක්. හෙත් මේ විදිහට තමයි ලියන්න ඕන. හරිද? මේවත් velocity කියන ඒවත් you should write like meters per second, right? You can't keep like this meters per second. I think you guys got. Then the vector quantity, same vector quantity came here. මේකට direction එකක් තියෙනවා ළමයි. Okay, so acceleration also have because the velocity is taken here because velocity is also a vector. If there is a positive acceleration, that means අපි හිතමුකෝ the velocity is increasing with the time. හරිද? speed නෙමෙයි අතර මෙන්න ඕන word එක. velocity if it's increasing with the time, it's become a positive acceleration, and the velocity if it's become decreasing, it's called deceleration. Another word for the deceleration is the retardation. Okay, and as same as in previously we called about the uniform speed and non-uniform speed, same like that there is a uniform acceleration. That means oya check karot the acceleration at this first second 10 seconds later it's not changing, right? එකම අංකෙමයි තියෙන්නේ. 4 නම් 4ම තමයි. If it's become 4, it's 4 throughout the journey. So acceleration කියන word එක it's common, right? ඒකත් අහලා ඇති. You know in vehicles there is accelerator. Accelerator එකෙන් මොකද වෙන්නේ? What happen when you in bike if you like use your accelerator? What happen? It's increasing the speed, right? Here the acceleration is the velocity term now, so it's increasing the velocity. Then it's become a positive acceleration, but if it's become a negative one we are calling it is as deceleration. So acceleration කියන word එක මම හිතනවා මේ පැටලෙන එකක් නෑ, because you know accelerating කරන්නේ මොකද්ද? speed එක එලවන වාහන එක වැඩි කරන එක. හරිද? deceleration කියද්දි ඔයාලට තේරෙන්න ඕන it's something opposite from the acceleration. ඒකෙත් දැනගන්න ඕන තව formulas දෙකකුත් තියෙනවා. Instead of these two අපිට mean velocity හොයන්න දැනගන්න ඕන. හරිද? mean velocity කියන්නේ mean velocity මේ we previously හෙව්වනේ mean velocity මෙතන. When you find the mean velocity with that you got the total displacement divided by total time. But there is another way. But remember, note lamai don't confuse this concept with others, right? Only when the acceleration is uniform. I highlight only when the acceleration is uniform. Don't use this equation when the acceleration is non-uniform. අර එක එක විදියට speed velocities වෙනස් වෙන වෙලාවට නෙමෙයි acceleration එක uniform නම් විතරයි. මේක valid වෙන්නේ uniform acceleration නම් විතරයි. හරිද? velocity වෙනස් වෙනවා but acceleration can't be changed. ඒ වෙලාවට the mean velocity equal initial velocity plus final velocity divided by 2. Okay, so that part can be again used to find the displacement too. displacement එකත් mind පාවිච්චි කරන්න පුළුවන් mean velocity into time කියලා. mean velocity කියන තැනට මෙන්න මේකෙන් එන value එක දාන්න. හරිද? ඊපස්සේ ඒක time එකෙන් වැඩි කරපුවාම එන්නේ displacement එක. ඒව මතකේ තියෙන්න ඕන. Please keep these equations in your mind. But remember these conditions, right? Okay, let's move to some questions under the accelerations. So this is also from your textbook. It's telling a body that starts from rest and it is subjected to uniform acceleration for 6 seconds, after which it acquires velocity of 12 meters per second. So it's starting from rest. Then it come uniform acceleration for 6 seconds. Okay. Acquire 12 meters per second. What is the displacement of the body during this time interval? Since the acceleration you can use the mean. Okay. මේක කියනවා acceleration එක uniform ලු. ඒ හින්දා you can use the mean velocity. mean velocity එක මතක දර ගන්න විදිය initial and final velocity එකතු කරා ඒක දෙකෙන් බෙද්දා. ඒ කියන equation එකත් පාවිච්චි කරන්න පුළුවන්ලු. ඒකත් පාවිච්චි කරලා හොයලා දෙන්නලු යාලට displacement එක. හරි. ඔයාලා දැන් මේකේ link එක දන්නවා මේ අන්තිම වෙලේ කියා දුන්න equation එක නෙමෙයි. That is the thing that we already discussed in last. Okay, so mean velocity you can find first. Mean velocity equal what? Initial velocity. Don't use abbreviations when you are writing. You have to write it fully. Divide by 2. Initial velocity එක මොකද්ද? It start at rest. That means the initial velocity is 0 meters per second. 0. Then the final velocity 12 meters per second. Divide by 2 means this answer is 6 meters per second. Then you know how to find the displacement. Displacement equal what? Mean velocity Never mind my letters because my letters are not fine, right? Mean velocity is 6 meters per second and the time is for 6 seconds, right? Here 6 seconds. Now the answer 16 to 6 36 meters, right? Here to here cancel වෙනවනේ. Displacement in meters. So you have to consider about the unit, right, when you are keeping the answer. එච්චර තමයි ළමයි ඒක. ඊට පස්සේ අපි තව මේ question එකකට යමු. A body start from rest. That means the initial velocity is 0 meters per second. It accelerate for 4 seconds. Acquire final velocity what? 12 meters per second. ඔය තියෙන first 4 second වලදී කතාව. So first question asks, you can pause the video and answer. What is the acceleration during the first 4 seconds? You can pause the video and answer. So the acceleration equal change of velocity, right? You can write change of velocity over time. It's not clear, right? You can write your equations. So what is the change of the velocity? Final velocity minus initial velocity divided by time. Remember to put the units, okay? So the answer is 3 meters per square seconds. How to pronounce this? This is 3 meters per කියන්නේ minus ඉර තියෙනවා නම් per කියනවා අපි. හරිද? Per square seconds. Square කියන්නේ ඇයි? දෙක තියෙන හින්දා square seconds. Okay, the ඊට පස්සේ මොකද වෙලා තියෙන්නේ? After that it move at a constant velocity of 12 meters per second. Then එයා acquire කරගත්තානේ 12 meters per second. ඒ constant velocity එකෙන් it will move for 4 seconds and ultimately come toward the rest. Ultimately rest එකට after decelerating for 2 seconds. ඔන්න first 4 seconds වලදී accelerate වෙලා ඊට පස්සේ constant velocity ගිහින් ඊට පස්සේ accelerate වුණා ඊට පස්සේ decelerate වුණා. ඒ කියන්නේ වේගය වැඩි කරගත්තා, constant ගියා, වේගය අඩු කරගත්තා. ඒක තමයි උනේ. දැන් අහනවා find the deceleration during the last 2 seconds. Deceleration කියන්නේ acceleration එකේ negative දෙනේ. ඒකටත් අපිට ඕන නම් එකපාරම acceleration කියන එක දාලා ලියන්න පුළුවන්. එතකොට අපිට එන්නේ negative උත්තරයක්. අපි acceleration හෙව්ව last 2 second වලදී change of velocity කියලා ලියන්න, over time කියලා ලියන්න. ඒ change of velocity එන්නේ මොකක්ද? මොකද change of velocity එක 12 වෙලා ඉඳලා ultimate come to the rest නෙවෙන්නේ. rest කියන්නේ 0. එතකොට initial velocity එක වෙන්නේ final velocity එක වෙන්නේ 0. initial velocity එක ඉන්නේ 12 වල. ඒකට යන time එක 2 seconds. එතකොට මේව ඔක්කොම units දාලා ලියන්න. ලිව්වහම වලට උත්තර එනවා 6 meters per square seconds. හැබැයි එන්නේ minus. acceleration minus එනවා කියන්නේ deceleration නම් එක හරිනේ. acceleration negative acceleration එකක් නේ deceleration කියන්නේ. ඊට පස්සේ ඔයාලා ලියන්න පුළුවන් deceleration equal minus mark එක අයින් කරලා 6 meters per square seconds. මෙහෙම ලියලා තිබ්බොත් මේ ළමයා වැරද්දක් නෙමෙයි කරන්නේ. මෙයා හරියට තේරුම් අරගෙන ලියලා තියෙනවා. Okay, there is nothing wrong with this, okay? You can't, because it's asking deceleration, you have to write again this is deceleration and without this negative mark. Then asking what is the displacement of the body during the 10 seconds. Asking about the displacement, right, during the 10 seconds. Okay, how to calculate the displacement? Okay, during the 10 seconds. So first it travel 4 seconds and then with the uniform velocity again 4 seconds and then 2 seconds it's decelerating, right? Now asking about the displacement. So how to find it? You can go through with each case, like means how much displacement travel means for the first 4 seconds and how much displacement for the uniform velocity, likewise you can calculate like that too. Students, as the time is limited, I use the answer sheet. Okay, so when it's come to the displacement, you have to separately go through with each case. At the first it go with this acceleration, and then with the constant velocity, and then the deceleration, right? So at each case you have to find the displacement separately. So as it is a uniform acceleration, at uniform accelerations or uniform decelerations, okay, both same, right? Only the difference is the something is increasing and other case it is decreasing the velocity. So you can use this same equation for the uniform acceleration and the uniform deceleration case. So in here, mean velocity into time. You know how to calculate the mean velocity? Initial velocity plus final velocity divided by 2. So in first 4 seconds, initial velocity is 0, then it's become finally 12, and that divide by 2. Then the time is 4 seconds. The answer becoming 24 meters. And when it's come to the uniform velocity case or the constant velocity case, it's easy because velocity equal normal velocity equal displacement divided by time, right? So if you want to calculate displacement, what you should do, you have to cross multiply, or you can to remove something from the denominator, you have to multiply it by both sides. As time is the thing in here denominator, you can multiply the both side by the time. Then what happens, this time to this time is cancelled, only in this side the displacement is remaining, and then displacement is equal to what? Velocity into time. That's what written in here. Okay, so uniform velocity into time equal 12 into 4, it's becoming 48. And in the deceleration part also, as it is a uniform thing, you can take the same equation, initial velocity 12, final velocity 0, then divide by 2 and into time, then it's become 12. The total displacement then you can calculate separately, 24, 48, 12, add up together, it's becoming 84. Okay, that means the object is 24 meters far away from its starting point, its finishing point here. So it's become 84 meters. I think you guys understood more clearly. So that is the answer for that. And there are some other questions. Let me go through quickly. So if the velocity of an object increases uniformly from 0 to 12 during 6 seconds, what is the acceleration? So acceleration equal what? Change of velocity, or the final velocity minus initial velocity divided by time. It's become 2 meters per square seconds. I will not remind every time, pause the video and write it first. You guys can do it alone. Okay, so the second question asking about the deceleration. So for the deceleration, we don't want to write the deceleration, first write acceleration, first find acceleration, then definitely that answer becoming a negative, then you have to write the deceleration without the negative mark. So the same way for the acceleration, the final velocity is what? 4, initial velocity is 16, then its time is 4, write the units, write unit in each case, then here 12 over 4, 3, right? 3 meters per square seconds. Never mind about the calculated final answers, right? Because this is not maths, and I don't want to teach you the maths because it can be done with your calculators too. So focus more on not only my answers, just focus the concept. Okay, then it's become minus, that means this is a deceleration, so you can write deceleration equal 3 meters per square seconds. Then the third one, starting from rest, if an object travel with an acceleration of this much for 10 seconds, find the velocity of object at the end of the 10-second period. What this mean? Here you know the acceleration, right? You know the time. Here asking about the at the end, no? That mean asking about something that is final velocity, right? Starting from rest mean it is the initial velocity. Usually in physics lamai this trick එකක් තියෙනවා. If you know the equations, you have to target in each statement what is the information can be used to put that into our equations. මම එහෙම තමයි trickily කල්පනා කරන්නේ. So I saw that rest mean the initial velocity. I saw that acceleration word. I saw the time word. Here the time, right? Time. This is the acceleration. And I got this is the at the end asking about the final velocity, right? Because after end of the 10-second mean. So if you see these words and if you analyze that part, that means you can find what the equation I can use to calculate this thing. As we know, acceleration equal final velocity minus initial velocity over time. Now I know the acceleration, now I know the time, now I know the initial velocity. They are asking about the final velocity, right? So you can find it using this equation. So acceleration is what? 0.5. Use the units. Asking about the final velocity, I will write this as a symbol v. Initially 0. That means this whole part becoming again v. Then time is what? 10 seconds. So how to solve this? You can multiply here by 10, then it's become 5. Then it's becoming v. Because v minus 0 is again v, no? So here if you multiply, it's becoming 5. So this answer is 5 meters per second. That is the final velocity. Okay, and again the next question, the velocity of an object moving on a straight line was 2 meters per second at a certain instant. Its velocity changed to 6 meters after accelerating for 4 seconds. Find the acceleration, right? It's also easy, right? Because the same equations you have to use. I will do it in here, right? Number 4. Acceleration equal final velocity. Don't use my abbreviations. Again and again I am telling. You have to write completely final velocity minus initial velocity over time, right? The final velocity is 6 meters per second. Then you have to write the unit. 2 meters per second is the initial velocity and the time is 4 seconds. Then 6 over 2, 6 minus 2 is 4, 4 over 4 means 1 meters per square seconds. Okay, this is the acceleration. Fine, right? We already completed the main theory parts in the starting from the distance, displacement, speed and velocity, and then finally the acceleration. So we did the huge part of this lesson. Next we have only to use these physical quantities with the time graphs and do some calculations. That's the next part of this lesson. Okay, so let's move to that part. That is the last parts, because we have to talk about the gravity also. So if you go through with the displacement and the time graph, you can see. First I have to mention about the graphs, right? In maths we are using graph to show how some quantities are vary with another quantity, right? So we already said displacement is changing with its time. So you can plot a graph, right? That's what did in here. Because අපි මෙහෙම table එකක් දිහා බලනවට වඩා in our mind it is more easy to understand a graph. අපි ඒකනේ දෙයක් අඳින්නේ. අපි ඒකයි, that's why we are drawing something on a graph. Because if it's a number table or something, it's not going it's not coming to our mind as a clearly what's really happened. Okay, so that's why we are drawing these graphs. So let me erase this. Okay, you know, in x-axis what is there? Usually in the x-axis we are labeling the time, and the y-axis we are using the displacement in displacement time graph. Okay, so if you think, first you need this data in a table, right? This table is you are usually converting as a graph. So you can see at the 0 second its displacement is 0, so it is the point. So in the time first second mean here displacement is 3, that means you have to go above and label as this point, so it's labeled as this. And the time is 2 seconds and the displacement is 6, so you come here and here mark as here. So at the 3 it is 9 from the displacement side, so you are labeling as here. Likewise, if you plot this and if you draw a line passing through all the points, then you got the graph like this. So if you focus on here, it is a straight line, right? So if it is a straight line in a displacement time graph, what it really means is it is a uniform velocity. Remember, if it is a straight line, that means it is a uniform velocity. If it's like curvy or something, it is non-uniform velocity. So that is the first point you have to keep in your mind. And very, very important thing is the gradient of these graphs. Okay, in displacement time graph we are only calculating the gradient, but in velocity, if you are moving to the velocity time graph, we are calculating the area too. So that is another concept. Keep remember, displacement time graph we are calculating gradient. In maths we learn gradient is what? Y difference. That means the y coordinate දෙකක් අරගෙන ඒකේ difference එක ගන්නවා. Y coordinates කියන්නේ මොනවද? This is y, this is x axis, right? මේකේ points දෙකක් ගන්නවා කියන්නේ if you take 9 and 3, these are y coordinate points. And also divide it by the x coordinate difference. If you choose this, you can't choose this and this, right? If you choose 9, its corresponding x value should be taken for this below value. So let me write 9 minus 3. If you take for the 9, what is the x value corresponding? 3, right? So 3 minus, if you take 3 in displacement, what is corresponding x of its value? That is 1, right? So you have to use 1. You can't interchange like 5, 3, whatever the thing that is in upper one to put in here. So 9 minus 3 is 6. 3 minus 1 is 2. Answer is 3 meters per second, right? Because this gradient of this displacement time graph is giving velocity. In the exam, if you forget what is we are calculating from this gradient, you can write. You know y coordinates is for what? Displacement, right? For the x coordinate it is time. So if you write y difference divided by x difference, what is coming? It is velocity equation, right? Displacement divided by time. That's the way you have to work out. හැමදේම අපිට by heart කරන්න බෑ. So you have to think if you couldn't remember at that point. So that is displacement time graph. So අපි question එකක් බලන්න ඕනේ. I think displacement for the displacement time graph we don't have, right? I think I didn't put yet. After doing the velocity time graph, let me explain the questions from both cases. So that is about the displacement time graph. Then this is the velocity time graph. So same way as in the displacement time graph, if we plot the velocity and the time, you can see at the 0 second time is 0, the 3 means the at the first second it's 3 meters per second, likewise it's changing, right? So if you plot that in a graph same as that way, the time is coming to the x-axis and the velocity which is changing with the time coming to the y-axis. That is a rule, right? That is changing is in the y-axis, this is x-axis, and so in first second velocity is 3, so you go like this and mark that point. At the second velocity is 6, so coming like this, mark like this. If you plot these and then join, that is the graph, right? එහෙම data points ටිකක් දීලා if you want to draw, you can draw කරන්න තිබ්බොත් you have to draw it, then use a ruler to combine these points, right? නයාරිනා වගේ අඳින්න බෑ, you have to draw it with the ruler, because in this O level you don't want to draw curves. You're not, unless you're not doing combined maths or something in your A levels. I don't have an idea because of biology, so I don't know really, because in the physics also we don't draw graphs like curves and everything, but we know what really means from those curves. These curves come under the advanced level physics, so only on your level the straight lines are coming. Okay, here the straight line, that means here if it is a straight line it's mean uniform velocity, but in here is in velocity time graph it's becoming uniform acceleration. That means in this graph if it's for showing this kind of a line, that means it is uniform acceleration. And also if it's become like a constant line, that means horizontal line, it is constant velocity. Okay, that is the difference. In velocity time graph, if it's like a horizontal line, it is constant velocity, but in displacement time graph it should be this kind of a slant line, not this kind of line. And also remember, in displacement time graph if it's become a horizontal line, what it means, think if it's like 18 meters, think at the first second also it is 18 meters, at the second also 18 meters. That means what? Does this object is moving? No, right? Displacement is constant in each second, that means this object is at rest here at constant velocity. Those points should be in your mind. ඒක නම් වෙනම note down කරලා තිබ්බත් අවුලක් නැහැ. Okay, but in here this is uniform acceleration, right? This is constant velocity because you know first second එකේ බලුවත් 6 meters per second, 4 second එකේ බලුවත් 6 මයි. ඒ වගේ velocity එක වෙනස් වෙලාවද පොඩ්ඩක්වත් නැහැ. එහෙනම් එයා යන්නේ constant velocity එකකින්. ඔයාලට පේනවා මේකේ velocity එක එන්න වැඩි වෙනවා, එහෙනම් එයා accelerate වෙනවා. And also think in this way, මෙන්න මෙහෙම graph එක තිබ්බොත් ඒකේ mean එක මොකද්ද? end velocity එක අඩු වෙනවා. එහෙනම් එයා තියෙන මොනවද? මේක හරි straight line එකක් වෙන්නත් ඕන. uniform opposite word එක deceleration. මෙන්න මේ තුන දන්නවා නම් shape එකෙන් කියන්න එතකොට හරි. ඒ වගේම displacement time graph එකේ straight horizontal line එකකින් කියන්නේ මොනවද, මේ slant කෙලින් line එකකින් කියන්නේ මොනවද කියලා දන්නවා නම් ඒ හොඳටම ඇති. That's enough for your level. And as I said, in this graph gradient is velocity, right? But in here what is the gradient? If you take the gradient is what? Y difference divided by x difference. Under y it's coming velocity, under x it is coming time. So it's coming velocity change divided by time means that is acceleration. But if the line is like this, that means the deceleration you are finding as the gradient. Okay, so another special thing then from the displacement time graph coming here is the area under the graph. Okay, area under the graph. What that really mean? Area under the graph. You know, usually the acceleration, deceleration showing with this kind of a triangle areas, right? You can say this area is which kind of shape? Triangle, right? So if you want to calculate the area of this graph, so it is basically a triangle. That's why it's telling us triangle area. දැන් maths වල ඉගෙනගෙන තියෙනවා triangle එකේ area හොයන්නේ කොහොමද? half into base of that triangle into height. මම නිකන් කිව්වොත් මෙතන what is the base length එක වෙන්නේ කොච්චරද? මෙතන ඉඳන් මෙතෙන්ට 6, right? 6 half into 6 into height එක කොච්චරයිද? from 0 to 18, right? That means 18. ඕක solve කරපුවාම එනවා මෙහෙම 3 into 18. 3 into 18 වෙන උත්තරේ ගන්න. I'm not calculating. That is the area. Right? ඒ area එකෙන් මොකක්ද කියන්නේ? area under this graph is called as the displacement. මේක ඔක්කොම පටලන්න බෑ. හරිද? area under the graph එකෙන් කියන්නේ displacement. So මේ area එකෙන් එන්නේ මොකක්ද? displacement එක මේ 0 second to 6 second වෙනකම් මේ object එක travel කරපො. හරිද? so මෙතන නම් rectangle එකක්. අපි හිතමු මෙන්න මෙතන sorry එතන ඉන්නේ triangle එකක්. අපි හිතමු මේ area එක ගන්න ඕන මට කියලා. uniform velocity නැත්නම් constant velocity එකෙන් යා මූණ area එක ගන්නවා නම් එතකොට මට එන rectangle එකක්. you know how to take the area of a rectangle. rectangle එක මේ උසයිනේ වැඩි කරන්න තියෙන්නේ. how much is it? This is 6 and this is 8. So 6 into 8 equal 48, right? So that is the displacement. ඒ කියන්නේ යා කොච්චරක් move වෙලා තියෙනවද displacement එක 0 to 8 seconds යද්දී. ඒ වගේ අපිට ඕන තැනදී කිව්වහම if it's asking about until 4 seconds, you have to only take the area of this part. 4 seconds විතර නම් අහලා තියෙන මේ කැලේ විතරයි ගන්න. Likewise, if they ask until this 4 seconds here, you have to only take the area of this part. Don't take until this. I think the theory part is okay until now about the graphs. We'll go through with the questions. So I think then you guys can understand more. Let me go through with the displacement question first, right? This is your textbook and I'm taking question from there for the displacement too. Nice question. This is a displacement one. So I'm not explaining these things because I already in my videos I explain about what is scalars and what are the difference between scalar and vector, and you have to know what is coming to the scalar. And with this look I can say these two are vectors and these two are scalars, right? So now they're given a displacement time graph, right? This is a displacement time graph. So first question asks, how far has the object moved? I will write how far the object has moved after starting from the rest. So this is 0, this is and the end of the journey. So after starting from rest, how much distance or how far it's moved, it's obvious, right? From 0 to here, how much it's travel? 10 meters. That means at the end of the 4 second it travel 10 meters. When it's asking about how far that is moved, that means they are asking about the distance. කොච්චරක් දුර ගිහිල්ලාද? They are not asking from the starting point. නැත්නම් starting point එකේ ඉඳන් කොච්චර දුරක් මෙයා ගිහින් ඉවරද කියලා නෙමෙයි අහන්නේ. කොච්චරක් දුර ගිහිල්ලාද කියලා නේ අහන්නේ. So total distance එක මේ අහන්නේ. So you can write from 0 to 8, right? Okay. So first he traveled about 10 meters. What happened then? Displacement constant here. That means what? what is this motion? This is uniform velocity. අන්න ඒව තමයි එකටම ඔයාලා recognize කරගන්න. This is uniform velocity. Here no motion, right? Because the displacement එක වෙනස් වෙලා නැහැ පොඩ්ඩක්වත්. Here what happened? Again uniform velocity. But only change is direction එක මාරු වෙලා. Here මේ direction එකට යන මේ direction එකට තියනවා කියන්නේ direction එක මාරු වෙලා. එච්චරයි වෙලා තියෙන්නේ. Okay? And finally become the displacement 0 කියන්නේ මොකද වෙලා තියෙන්නේ? Starting point එකෙන් පටන් අරගෙන ආයෙ ගිහිල්ලා starting point එකටම ඇවිල්ලා. That's why the displacement becomes 0 at the end of journey. Anyway අහන්නේ දැන් distance නේ. First එයා ගිහිල්ලා තියෙනවා 10 meters. එයා ඊට පස්සේ මූණවි නිකන් ඉඳලා ආයෙ ඔයාලට පේන displacement එක 0 වෙලා. So displacement again becomes 0 mean coming back to the starting point. එහෙනම් starting point එකේ ඉඳන් 10 meters ගිහිල්ලා rest කරලා ටික වෙලාවක් ඉඳලා ආයි starting point එකට ආවා කියන මීනින් එකනේ තියෙන්නේ. ඒතර 10 meters ගිහින් 10 meters ඇවිල්ලා. ඒක තමයි මට තේරෙන දේ. So මම ලියන්නේ 10 meters plus 10 meters. එයා ඔක්කොම ගිහින් තියෙනවා 20 meters distance එකක්. හරිද? ඒක graph එක දිහා බලලා තමයි මම distance එක කිව්වේ. මොකද there is no like any equation to find this from this graph, right? So how long has it taken to travel the above distance? කොච්චර වෙලාවක් ගිහිලා තියෙනවද මේක distance එක travel කරන්න? With this you can see it is 8 seconds, right? Find the maximum velocity of the object during that period. Maximum velocity එක අහනවා. හරිද? අපි මෙතන velocity එක හොයුවා නම් මෙතන velocity එක බලන්න පුළුවන්. මෙතන නම් motion එකක් නැති නිසා velocity එකක් 0, right? 0. මෙතන velocity එකත් ගන්න පුළුවන්. එතකොට අපිට කියන්න පුළුවන් මොකද්ද maximum එක කියලා. මෙතෙන්ට velocity එක හෙව්වොත් කොහොමද වෙන්නේ? එතන velocity එක ගන්නේ කොහොමද? You know the in displacement time graph the gradient is the velocity, right? So gradient equal velocity. So gradient equal y difference over x difference. You have to write inverse, right? So y difference එකට එන්නේ මොකක්ද? 10 minus 0. ඒකේ විදිහට දාන්න 10 minus 0 and for the x difference 4 minus 0 is 4. Then 2.5, right? 5 over 2, right? Yeah, 2.5 meters. Sorry, velocity no? Yeah. මෙතන velocity එක මේක. මෙතන 0 මෙතන 0 meters per second because there is no any motion. මෙතන velocity එක හෙව්වොත් ආයෙත් අර විතර ලියන්න gradient equal y difference over x difference which is the velocity and මොකද්ද y difference එක එන්නේ මෙතන? ඒකෙත් එන්නේ 10. හැබැයි x difference එක වෙනස් කීයද? 8 minus 2 8 minus 6 කියන්නේ 2. එතකොට එන්නේ මොකද්ද? 5 meters per second. හරිද? එතකොට මෙතන 2.5 meters per second මෙතන 5 meters per second කියන්නේ maximum velocity එක කීයද? 5 meters per second. එයානේ maximum velocity එක. මෙයා නෙමෙයි. හරිද? How can you say about the motion during the interval from 4 to 6 seconds? 4 to 6 seconds වෙනකන් what can you say about the motion? මං කිව්වා එතන මොකද වෙලා තියෙන්නේ? The displacement has not changed throughout this time gap. That means it is at rest or no motion. Comment on the motion during the interval from 6 to 8. What happened during the 6 to 8? Displacement 0 වෙලා තියෙනවා කියන්නේ මේ යම් කිසි අතකට ගිය කෙනෙක් ආයෙ direction එක මාරු කරලා ඇවිල්ලා තියෙනවා. So ආට කියන්න පුළුවන් it is moving under uniform velocity because this line is straight, right? Straight නම් uniform velocity again come back to starting point by changing direction, but or the coming back to the starting point by traveling to the opposite direction. එහෙම මොකක් හරි ලියන්න පුළුවන්. Okay, ඒක තමයි මම ඩිස්කස් කරන්නේ velocity time graph එකට with the time limitations. I'm not making this a very long video, so I won't like any velocity question. I'm guessing what kind of question. We'll move to this question. I have no preference to any kind of question because this is my first time of going through with these questions after a very long time because I cannot remember at what time. I did my O-levels in 20 20 all level batch, so it's how far. So this is my first time going again. So if the velocity of a body varied uniformly from 10 to 25 during a time interval of 5 seconds, what is the acceleration of the body? This is not asking about the graph, right? Graph you can go through with the equation. So what is the acceleration? Acceleration equal final velocity minus initial velocity divided by time. I repeat, don't use abbreviations, write as final velocity likewise. So final velocity 25, 10, time is 5 seconds. So 15 minus 10, so 25 minus 10 means 15. 15 over 5 means 3, right? 3 meters per square seconds. That is the acceleration. They are asking to sketch the velocity time graph for the above mentioned motion and find the distance traveled during the 5 seconds. Let me erase this part because of the space problem. So this is a graph, right? Then what happened? If it is a velocity time graph, you have to label the graph and you have to write the unit as well. Remember, Lamai? You have to label the what is the axis and what is the unit, and then put 0 here. Then with equal gaps, මේ වගේ පේනවනේ equal gaps තියෙන්නේ කියලා. 3 මෙහෙම මාක් කරලා 6 මෙතනින් මාක් කරලා 12 මෙහෙම මාක් කරන්න බෑ. There should be equal gap. මේ 3 gap එකක් නේ තියලා තියෙන්නේ. So it is equal gap වෙන්නත් ඕන. හරිද? ඒ වගේ අපි හිතලා equal gap එකක් තියෙන විදිහට මම මාක් කරන්න ගන්නවා. 5 seconds තියෙන. එහෙනම් මම ලස්සනට 1 2 3 4 5 කියලා මාක් කරනවා. Then until 25 නේ තියෙන්නේ. එහෙනම් මම 5 10 15 25 වගේ මාක් කරනවා. මොකද it's not practical to write 1 2 3 4 until 25. ඒක වෙලා යනවනේ, එහෙම බෑ. easy method එකක් use කරන්න ඕන. So මේක කියන්නේ ඒ object එක move වෙලා තියෙන්නේ 10 seconds to 25 නේ. එතකොට 0 වලදී කීයෙන්ද පටන් ගන්න යා? 10 seconds. So it's starting at the 10 and it's ending, that means at the 0 second its initial velocity is 10 seconds, 10 meters per second, and at the end of the 5 seconds it's becoming 25. Little bit hard because there is no any square rules, right? So you have to draw straight line by joining both. This is the graph, right? That is the way of drawing it. So then asking about the distance. You know, in this velocity time graph, area under the graph is what? That is the distance, right? So you have to calculate this area. Now tricky, right? Because what is this shape? For me, this is a trapezium. Harita, this is a trapezium. So I see this trapezium as this way. Wait. I see this trapezium as this way. This is my base, right? I see this is as base because it's longer than this side. And this is my perpendicular distance. So maths, I cannot remember at which point you are learning the equation for the area of the trapezium, because I'm really sorry for that because it's not in my mind now. Anyway, learn from now. When you're taking the area of the trapezium, it's become half into, you have to add the these opposite side lengths. Okay, that means from here to here the length is 10, here to here the length is 25. That's mean 10 plus 25, and we want to know the perpendicular distance between these bases. Okay, these two bases. You can see this is a slant line. This is a slanted line. It is joined by two parallel lines, two parallel lines joined by this slant line. So these slant lines are added up like this in here. It is multiplied by half, and you have to know about the perpendicular distance between these two parallel lines. It is 5, right? So 10 plus 25 is what? 35 into 5 divided by 2. So answer is coming. This is 87.5. Okay. Then the next question is, this is like distance or meters, right? Okay. Now the next question is, the variation of the velocity of a certain object that travels along the straight line is shown in the graph. Okay. So let me delete. Okay. So now this is a velocity time graph. So they are asking about the acceleration during the first 6 seconds. So before we are moving to the question, you can analyze each and every part of the graph. This part is what? In uniform velocity coming like this in the displacement time graph. But in here, this is uniform acceleration, right? This is velocity is not changing with the time. That means uniform velocity or the constant velocity. Here direction change, but again uniform thing, again opposite to the acceleration, that is what? Uniform deceleration. You can see the velocity is decreasing with the time. This is velocity increasing with the time. So asking acceleration during the first 6 seconds. This is acceleration. So what is the acceleration? You know, in velocity time graph, the gradient equal acceleration, right? Y difference divided by x difference. What is the y difference? This distance. 6 minus 0, x difference. 6 minus 0, then 1 meters per square seconds, which is the acceleration. Then find distance traversed by the object during the first 6 seconds. In velocity time graph, how to find the distance or the displacement? Same in here, right? Because when you can find the displacement, that means originally that is also kind of a distance. Okay. What is the distance traveling this part? That is the area under the graph, right? Area equal what? This is the triangle, so half into what is the base length? 6. The perpendicular height is also 6, so 36 over 2, or 6 into 3, 18, right? Meters, because it is a distance. What is the distance transferred at the uniform velocity? Asking about distance in here. So it is like a square. Yeah, it's like a square or a rectangle or whatever. If you are not sure, it's okay, but it's the area, right? Area equal length into breadth. Length part is what? 12 minus 6. What is that length? 6. This part 6 minus 0, that is 6. 36 meters. These are not science, right? Because these are maths. And they are asking about the find the deceleration during the last 3 seconds. Deceleration. What is the deceleration here? This part. You know, deceleration is opposite of the acceleration. So this gradient give the acceleration. Let me find the acceleration first. Then the definitely a negative answer should come. Then we can write it is oppositely writing the positive sign and write it as deceleration. So the gradient equal y difference. What is the y difference here? 6. What is the x difference here? 15 minus 12, 3, right? That is 2 meters per square seconds. But here in y difference, how you are writing is you are taking here, right? In here we took any acceleration, 6 minus 0. Here 6 minus 0, the 0 here starting from 6 and ending on 0, no? So final one is 6. Sorry, final one is 0. 0 minus 6 over 3. So you can see it is 2, but it's minus, right? But in here the final one is 6. Here initial one is 0. So it is opposite. Okay, anyway, when you are calculating, the answer is 2. You know, that is the deceleration. I think you got a really and what we learned in theory and what it's, but when it comes to the question, it's a little bit of difference, and you will exposing how to calculate these things. I hope you guys understand this lesson, the major parts. Now we are moving to the very small part, that is learning. This is like very small part. They mention about the gravitational acceleration, right? Or the simple g. We are using simple g to represent the gravity. අපි දන්නා ගුරුත්වාකර්ෂණය කියලා කියන්නේ. Gravity එක කියලා එකක් අහලා තියෙන අර නිව්ටන්ගේ ඔලියට ඇපල් ගෙඩියක් වටනවාම he thought that it is gravity because of that apple is fallen on his head, right? That Newton's scene is coming under this gravity. It is actually a force, right? Forces ඔයාලා ඉගෙන ගනි in the upcoming lessons. That is a force, and gravity is a force. Here we are talking about the gravitational acceleration. The acceleration causes by that force. Okay. ඕනම object එකක් when it's come to the earth, it is attracting toward itself. earth එක ඇද ගන්නවා තමන්ගේ පැත්තට. So with that gravity force, so ඒක එන acceleration එක ගත්තාම ඒකේ value එක අපි measure කරලා බලුවොත් එන්නේ මේ වගේ amount එකක් 9.8. හරිද? එතකොට downward කියන්නේ earth එක පැත්තට ඇදගන්නේ. upward motion එක ගණන් හදනවා නම් අපි ඒක පාවිච්චි කරන්නේ minus කියලා. ඒ වගේ පොඩි දෙයක් දැනගන්න තියෙනවා. ඒක තමයි ඒක දැනගන්න ඕන part එක. ඒක දැනගන්න ඕන මෙන්න මේ වගේ part එකක්. You should learn only this kind of thing. If you drop a ball, think it's like a ball. If you drop a ball from a height, right? If you drop a ball from your height, from your hand, what happen? It start falling, right? Initially its velocity is 0, right? In your hand it is 0. If you start dropping it, what happen? At each second, at every 1 second, its velocity is increased, but with 9.8 meters per second, it is increasing because gravity is accelerating that with this much of amount. Gravity එක තමන්ගේ පැත්තට එක සෙකන්ඩ් එකකින් එක සෙකන්ඩ් එකට 9.8 ගානේ වැඩි කර කර තමන්ගේ පැත්තට ඇද ගන්නවා. That is the meaning of the gravity, right? So first second එකේදී මෙච්චරයි, double second second එකේදී එක double වෙනවා, ඊට පස්සේ triple වෙනවා. හැමෝම පොළවට වැටෙන ගමන් මොකද වෙන්නේ? 9.8 ගානේ එක සෙකන්ඩ් එක සෙකන්ඩ් එක ගානේ velocity එක වැඩි වෙනවා. Okay. So like a graph එකකින් අපි velocity time graph එකක් if you draw for that motion, you can get like this. Okay, you know this is a uniform acceleration, this line. So if you want to how much distance that ball is travel, you can take the area under this graph, and if you find the gradient, you can get the answer as 9.8 meters per square second, which is the gravity value. Okay, and also if you do the opposite, then අපි කරේ ball එකක් උඩ ඉඳන් අතෑරපු එකනේ. But if you throw a ball upward, ball එකක් උඩට අතෑරියොත් ball එක හසට කඩාගෙන space එකකින් කඩාගෙන උඩට යනව නෑනේ. ඒ ball එක තැනකට ඇවිල්ලා නතර වෙලා ආයි පල්ලෙහාට වෙන්න පටන් ගන්නවානේ. දැන් අපි මේ උඩට ගිහින් නතර වෙන තැනට වෙනකන් විතරයි කතා කරන්නේ. If you throw a ball, it will go upward and rest at point, and it start coming back to your hand again, right? So that is until here, this motion is analyzed here. At the beginning, in your hand, you give a push of 20 meters per second velocity to the ball. Then what happened? At each second, it reduce its velocity and come to the 0. Why it's 10, right? Why it's 10? You know it's 9.8 meters per second should be reduced because gravity is attracting toward itself with this much of acceleration. එතකොට මොකද වෙන්නේ? For our easiness, for our convenience, we are taking this 9.8 as it is so close to 10. We are take this value as 10. එහෙම තමයි අපි A levels වල පවා ගණන් හදන්නේ. 10 කියලා තමයි එරන් ගණන් හදන්නේ. ඒකයි කියන්නේ first පටන් ගද්දි 20 meters තිබ්බගෙන එක සෙකන්ඩ් එකක් යද්දි මොකද වෙන්නේ? 10 meters per second වෙනවා උඩට යද්දි. අයියේ gravity පහළට අදිනවා. පහළට වැටෙන වෙලාවක ප්‍රශ්නයක් නැහැ. It is supportive for the gravity, so it is increasing. මේ බෝල මෙතනින් අතහැරලා බිමට දැම්මනම් මොකද වෙන්නේ? එක සෙකන්ඩයක් ඉදිරියේදී 20 30 වෙනවා. It's become 30 40 like that. It is increasing when it's going toward the earth, but it going upward away from the earth, it reducing its speed and becoming 0 because of gravity attracting against that motion. So if we draw like that, it become like this kind of graph. Okay, starting from 20 ending as 0. What kind of motion is this? This is uniform deceleration, right? It's no longer acceleration here. This is a uniform deceleration. Here also, if you take the area, you can find how much distance that ball travel. And if you take the gradient, it's give the deceleration value, which is also 10 here because of we usually use for easiness as 10. Okay, that's all I have to discuss here. If you guys have any questions under my lesson, feel free to put in comment section. I will further reply to the questions and doubts you already guys have. Hope you guys enjoy my video. See you in future videos.